ค่ะและลำดับต่อไปนะคะเป็นหัวข้อสุดท้ายก่อนที่จะรับประทานอาหารเที่ยงกันนะคะก็เป็นเรื่องของ Digital Radio ค่ะโดยมิสเตอร์แฟรงค์มัสซะนะคะตำแหน่ง Asia Pacific Sales Manager ค่ะจากบริษัท Elenos World Broadcast Experience ค่ะขอเสียงต้อนรับมิสเตอร์แฟรงค์วีมัสซะค่ะ
Good morning. Buongiorno. Sawasdee krap. Okay. How many of you all can speak English, first of all, or understand English? English language? Okay. I can speak Thai also, like the last presentation, but I'm going to do it in English, and if someone wants to translate, if you have any questions, I can go back into Thai, from Thai to English, or I could speak in Italian, or if you want in Russian or Polish, but I think today we'll stick to Thai and English. So let's see. Okay, I'm with a company called Elenos, which is new to not only Asia but also to Thailand. There we have several. We're going to be focusing on audio today and not TV. So the discussion will be about FM radio and also about the digital radio, which we call DAB. So without that, I'll just get started here right now and see. Hopefully I can get these right. Is it mine? Oh. Okay. Sorry. Okay. Is it already in? Okay, first of all, I'm going to start out with a DAB overview. Are any of you familiar with DAB? I know there have been some small trials here. DAB has, for the most part, been adopted in a few places, Australia and in the UK, and it's catching on in a couple other places. So there are three main technologies for digital audio, and we're going to focus on DAB today. So today, traditionally, as we know it today, as you use your radio in your car, in your house, or whatever, you typically use an AM, the older style radio, FM, which came in the 70s or so. Today, there are multiple digital radio standards. Unfortunately, it's like when the day the digital TV comes out, there's so many different standards and there's different ones adopted worldwide. The same was true for analog TV as well. But in digital radio, we have DAB was first, then DAB+, and then there's the TDMB. There's a technology out of, pretty much out of France, it's called DRM. And then there's HD is out of the US by Ubiquiti. I know there have been some tests here that have been done in Ubiquiti. I don't know about DRM, but definitely there's been some work done in DAB already. And then there's some digital that's also done in ISDBT. ISDBT is also the digital technology that for TV that's being used in the Philippines and a couple other places, I think Japan as well. So we're going to focus on what's run under what's called the World DMB and the DAB technology. DAB, according to DMB, is the widest accepted worldwide, but actually there's more installations of HD radio and Ubiquiti now because it's in the US and it's in Brazil and it's in Mexico. But worldwide, we're seeing more of a trend moving over to DAB right now. Okay, so originally we started out with what was called the Eureka family of standards, DAB in 1995. TDMB in 2006 added some video services to mobile as well. DAB Plus in 2007. So here we are in 2015, and we're still on the launch pad with only a few adopters really of this HD style, or let's just call it high quality audio for radio. You know, most countries are still using analog, but we're seeing migration, and let's see how it goes. I know that you have big plans here for DAB. 2.5 times more audio services than DAB, and the pad content now, program access data is much stronger with DAB+. So the DAB+ adds on top of what was originally done with DAB. DAB, I think, was launched in the UK and in Australia first without the digital video content as well. Okay, it should be pointed out that these are originated primarily through this DMB organization and through ETSI. So the main standards, if you want to read up on this and follow up with my presentation, is the EN 300 document, TR 101 and TS 102. So this talks about really about the transport of radio and so forth for this DAB. Features of DAB, basically you're going from analog to digital. That's the main the main feature. Again, as the gentleman before spoke, and we have more efficient use of the spectrum. However, you know, very, very similar technologies, and we're moving into band 3. So most of DAB moves out of the traditional band for FM radio, which is, let's just call it, aside from the Japanese band, which is down into the 70s, but 88 megahertz to 108 megahertz. DAB is moving up into band 3, which is, I'll get into it a little bit later. What can be done? What's being done, for example, in Australia, and what can be done? In Australia, they're keeping their analog frequencies, so they're still operating in 88 to 108. What they do is they've given equal competition for all the brands. So you have AM, FM radio, all operating with this digital technology in DAB in Australia. So you have the horse racing network and the news network and the rock network and the rapping network and news. They're all done from the same towers, and they share the same locations, and they're using the same digital technology. So the difference goes from having multiple TV transmitters to having one transmitter location using multiplexes, and just like with DVB-T2, DAB uses the technology ahead and equipment to provide many, many more stations and more efficiency than in that case. So the addition here is with typical audio. When you look at you're listening, your experience today with radio is, unless you're using an iPad or something like that and you're streaming, typically with a radio you look at, you're just listening to the experience, so you hear the sound. With DAB, you have some visual images, and there may be some pictures of album covers or things like that. So it gives the experience more closer than what you might get by streaming. But then again, it's a broadcast quality, and there's no charge for the service. So again, with the pictures, you get text, images, and it's all done within the audio stream. Okay, let's move on a little bit more and try to get into more of the nuts and bolts of this. What can be done with DAB a little bit different than normal radio is you can actually do the interrupts, announcements that can interrupt across the board to all stations. So you don't have to stop and have a news flash of flooding coming or amber alerts or emergency, something like that. You can do it at one station through traffic, news and weather, again, emergency warnings. Anything with the program types, rock, light classics, are all for the most part the same. Multiple languages are supported. I think this is the key where I've seen big advantages for digital radio, because you have, whether it's any of the standards and no different with DAB, you can have one station in Thai and then another station in English. And that would, for the most part, take care of a good percentage of the population. But in places like India or Bangladesh, we're seeing migrations over and planning for multiple language, like they'd have it in English throughout the country, and then also planning to have in their local languages by region, which there are about 30 or 40 of them. Let's see. Let me try to get down and get into some visualization. Today, this is a typical FM network here. And you can see I've got 1, 2, 3, 4, 5, 6. There's 7 stations here, and there's 7 stations here. They're all operating on different frequencies. Each station is, 14 FM stations. So basically, the output of each of these stations totals 45 kilowatts, or 45,000 watts. 45,000 watts typically is quite a bit. In an area like Mcot, typically you can get good coverage from 5 to 10 kilowatts with analog coverage. This information came from this group of head-end equipment called Factum. Let me see something here. Okay, with the digital spectrum, what we're basically seeing here is my data is contained here, unlike with HD radio, where I have a combined analog signal in the center, and then the 2 side carriers contain the digital information. DAB is a complete digital technology. And this is what the spectrum looks like without filters. It looks like this. So I'm looking at 10 dB down here. But I'm looking at another 20 dB down. This is my noise floor with an output filter. So generally we use for each of these stations operating on one frequency. It's a typical TV type channel, 6 megahertz. You're using one filter to be able to get this type of spectrum performance. Okay, so let's then move into DAB typical in Australia. And you can see that here are these band 3 channel assignments here, and they've put in 3 DAB ensemble here into 9A, which is 202 to 208. So in 6 megahertz, 3 ensemble, there can be up to about 30 different channels in that spectrum. Okay, now here's the difference. Now, you remember the chart before. I'm operating under a single frequency network, and we just spoke before about DVB-T2 and single frequency networks, and everything is controlled by GPS or controlled by some master clock, and the timing for these. And here I've got 7 different stations through a multiplexer at the head end, and everything is fed, and I have the same identical program. Now, 7 different stations could cover the major metropolitan area in Bangkok, depending upon how much power you're going to use. And we talked about coverage at 500 watts, 1,000 watts, 5,000 watts, 10,000. The difference in transmitter power, typically from digital to analog, is an analog transmitter at 10 kilowatt is about 2,500 watts in digital. And it's the power that's basically required because my receivers have much better receiver sensitivity, about 20 dB better performance. So I don't need as much power. On the other hand, the efficiency goes way down because I'm operating at a much cycle. So basically I've got up to here, I could do 20 stations in one DAB frequency, but here they're just showing 7. So I've got 7 different guys on the same channel. Typically here you might be able to do, if you're still operating your analog frequency network for a while and they understand that there's going to be a migration from the band, which is 88 to 108, I think 88 to 92 is going to be your community radio band, and above 92 to 108 will be all the traditional government radio frequencies licensed through like MCOT and the other brands as well. Okay. So the basics here is that I've got a lot of things going on at the head end, and I'm going to stay focused on what Elenos does. We work with any head end system. It doesn't really matter who it is because we have a standard interface here, but basically this is all my head end equipment as far as how many channels I put in, what kind of standard I'm working to, and so forth. And the cutoff point for it is here. So this is what we do. And so basically for our radio, we need our DAB plus transmitter, which is a digital transmitter, true digital exciter, digital output, so forth, direct to channel. The channel filter, as we showed before, is really important. And then we have our antenna system, which as we move up into band 3, the antenna systems are much smaller than in FM because they're the higher frequencies. So less metal, a lot better gain as they get higher up. Okay, so that's basically, let's say, a quick primer on DAB. And I know that there are some within MCOT that are very knowledgeable on what's been done in some trials and really familiar with the technical aspects. We can get into that at any time if needed. There's several different companies, I think, that are already have had discussions, and I can't go into them right now other than that there are the same ones that are involved with digital TV are also involved with digital radio as well. Real similar technology. And I'm going to talk about Elenos, our company, and just to familiarize you for Thailand, what we are and what we're a little bit different here. We come from the land of what we call technology and art, and we come from a part of Italy that is really the Silicon Valley of Italy. Now, I'm American. I was born in the U.S., but I'm 100% Italian ethnicity, so my family came from the U.S., and I happen to be born in New York. So working for an Italian company is like I've worked for several big U.S. broadcasters, and now working with an Italian company, it's like being with, it's La Familia. It's like working with a big family, and it's quite different, but very, very talented people. This is our marketing staff in Italy. We have been around strictly only in radio since 1977. I don't know, for some reason that slide didn't work. Since 1977, we have 40,000 FM radios installed worldwide. Elenos is a big provider in Italy, which has a lot of mountains and valleys, so the radio is important, and there's a lot of installations of radio. But that helped us in doing a couple of things of our technology. But this is our location, and I'm sorry, let me move back. Huh. Okay. This here is a typical production area, and this was one order that we did in 1 month for nearby company Myanmar, or a country, Myanmar, Pama, for a complete rollout of 38 stations. I mean, they went from almost having no radio technology to having technology of 38 stations that covered most of the country. So, we have that capability where we provide small, simple community radio stations all the way up to big networks. So, some of our customers are, and let's see if you know some of these, Deutsche Telekom, BBC World, World Family Radio. Maria is the Catholic network worldwide, and so they have several hundred Elenos radios. So these are some of our customers. Our product ranges go from small size 2 rack unit transmitters up to 30 kilowatt FM type radio. What's important is that a lot of this technology is used in this DAB that we talked about before, and I'm going to go into some of that technology. Ironically, whether you're digital or analog, whatever the case is, being an engineer first, and then, I don't know, I guess I have to call myself a sales guy. The lowest technology part of a TV or a radio type transmitter is the power supplies. The power supplies are the Achilles heel. You're nodding your head, yes, okay? Because you have all kind of fluctuations in power supplies. If you have something up in Udon Thani compared to something here in Bangkok, compared to something in Bang Sen or whatever, you never know what's going to happen to the power supply. I have lightning strikes, I've got high voltage spikes, I got brownouts, all kinds of things. So power supplies are still very complex. They're a low technology solution, but they have to be ruggedized to meet worldwide standards, that you have the highest grade in Bangkok all the way to a lowest grade of some small mountaintop in the middle of Nuang Bua Lumpu or Lue, something like that. So what we've been doing is focusing on planar technology, and I'll show you some pictures, but it goes out throughout FM or DAB products. The planar technology reduces the number of parts. A lot of companies are doing this now. Reduces failure, reduces the heat consumption, which is really important for both analog and digital. And so overall, the effect is increased efficiency. So today, we're not talking about DAB product that's water cooled or anything like that. Everything is still air cooled, and with air cooled, we get efficiencies and very, very high efficiencies in FM radio, for example, up to 75%. Okay, come on. Okay. I'm going to talk a little bit about something I run up against. I mean, being with prior to this, working with U.S. companies, the expectations were, or let's say European, German, Japanese companies, the expectation was always, okay, the quality's there because they're high industrial nations. When you go to something like Italy, the example is it's a different, entering the EU 15 years ago or whatever, it's a different expectation. However, the quality is wide. I mean, we see very inexpensive products coming out of Italy, and we see very high quality products. We position ourselves and we do everything as if we were a premium type company, and with all the major players from North America and from Europe. So what does that require? That requires having these type of standards, health and safety requirements, electromagnetic capability. This is so important. I mean, having a radio installed where there's police radios and other things, you don't want to have interference across the board. So we put a lot of effort into these compliance standards, and not everybody does them. You'd be surprised, at where you don't see this compliancy done, and it costs money. And it may make the price go up, but it's something that you absolutely have to have. Certification is important, so we again believe in the ISO certification. We're RoHS compliant, and also the ISO 14001, which is more green earth type compliance. This is an example of some of the planar technology, and what's really nice here is that you'll see that the miniaturizing the size of the equipment and putting more into a smaller spot really helps us in a lot of ways for transport. It helps us for repairs and so forth. But at the other time, really what you're seeing is a lot of this was done before with discrete components, inductors and capacitors and blah, blah, blah. Higher part level failures. When I put everything into the board like this and I have a high integration of this planar technology, it costs less because I don't have to have engineers sitting there tuning every little piece and so forth. So let me move forward a little bit now. A lot of folks have moved over to what we call an ICE-FET technology. Basically, we're running everything at maybe about 40 to 50% of the specifications. So the power amplifiers are not running to maximum. So we're keeping the power basically down. That keeps the temperature down as well. It also extends the life of the products. So for example, I mean, if you look at this, I mean, we know that we can get temperatures at close to 41 degrees centigrade. You know, here is the hottest temperature really that's running on this, and that's where the power amplifiers are at. We're only at 41C. This is incredible. In the past, you used to be able to warm up your coffee or even boil the water for your coffee on your equipment. We also believe in something called eco-savings, which, you know, not everybody thinks about the ecology of what we have in the world and our legacy of what we leave our children. However, it's a win-win situation. If I do this right, I'm going to be saving power, and you talked about efficiency also in your presentation just before me, but you know, the savings are really in operating costs. The savings are incredible. Today, your capital expenditure for transmitting equipment, you can save that cost as compared to 5 years ago. You can save it in 2 or 3 years. It's just absolutely incredible how much electricity we save. And electricity goes up and down in cost, but still it's something. It's an operating cost that's really important to manage. So we do that, and we have a technology that watches that carefully. We also have something called Life Extender. And Life Extender basically lets us be able to operate. If you lose your air conditioning, we're going to do things to the equipment to keep it up and operating as well as possible. And this is done in the DAB equipment, it's done in the FM equipment, streaming equipment, whatever have you. But importantly, what we do is we allow the programming to be done where we can get trends of how the signal reaches different areas over a 24-hour period, over a 1-month period, over a 1-year period, and we can program the equipment here to operate at, say, maybe 4 different power levels. So maybe my signal carries much better at nighttime, so I'm only going to use 25% of my power. Now, if my design is done correctly, and today you can design, and we've designed the equipment that when I run at 25% power, I'm actually using 25% of the power. Some equipment, you run it at 25%, you're still running 100% of your estimated power. So again, it becomes very, very efficient, and this is an example of ecology saving. This is important, and I think we're in the tropics, so, and I live here too, so I know what happens to metals. So dissimilar metals is a problem. We use all aluminum technology, or you know, non-corrosive, non-dissimilar metals, because you know, these can cause problems in grounding and so forth very quickly down the road. Power supplies, I'm not going to go into that detail right now. This is low-pass filter designs, and you can see this high integration of everything being done in circuit boards and etched in, as opposed to doing with discrete components. Big, big savings in manufacturing, big savings in longevity. For the DAB, we have, of course, a digital option. Everything today is done in this one chip, where before it was done in many, many, many components. So this chip here is basically, this is our entire digital exciter. Now, in 2003, we started to see radio exciters come out that were 4 rack spaces, 5 rack spaces high, that did everything that's done in that chip today. And this is incredible, because in this, I've got all my technology to do my SFN. I got a little daughter board that plugs in here also that does a GPS on board. So I can put a GPS receiver on here to do my synchronous FM, or I can synchronize externally, whatever I want to do. Okay, so without being said, we have something, the total control. We can control everything over IP networks, and that's pretty much standard now. And your engineers can walk around with iPhones or Androids or whatever have you, and still monitor everything, get messages, come fix me, I may have a problem. Today it's not so much in what the problem is and what's happening to the equipment, alarms or no alarms, it's what can happen. So you program it to say, oh, I'm seeing a degradation, and maybe in a week's time I'm going to have a problem with a power supply or a power amplifier. So you get in, the maintenance team says, look, I got to change this out, it's time to do some maintenance. A little bit of the screens, and we have the external devices which we can attach pretty much to any device. So this is all, I think, standard in the industry. We use what's called both a web technology for its low level. For MCOT, I'm sure you'd use an SNMP manager like HP OpenView or Castle Rock or what have you, maybe a private brand of some sort or something custom. Okay, what I'm going to do is I'm going to try to run through quickly a little bit about the DAB products, and then I'm going to show you some maps of coverage of what the DAB coverage looks like. And I think it'll be really similar to what you see with DVB-T2. So we have in 4 rack units a 300 or 600 watt unit. So it's 4 rack units, built-in exciter, everything's ready to go. You put the external filter on here. You could handle up to 20 or 30 or 40 stations with this. And I'll show you what the coverage looks like for 300 and 600 watts. I'm not going to go into these specs because I want to show you more things in picture and coverage, but this is what it looks like on the inside. Nothing different than what I had showed you previously. Some of the other features, SFN features are standard, direct-to-channel digital exciter, so it's not just a digital exciter, but direct-to-channel, I think, which is important. We support the DAB, DAB+, and TDMB standards with this. DAB modes 1, 2, 3, and 4. Just to get a look, I showed you a little bit of that screen. We use an OLED screen, or you can do something with the computer connected for more resolution, but everything can be done. This button is actually like a mouse on a computer that interacts with the screen and a series of LEDs. So, unless you're a technician guy, this kind of stuff is not going to get you excited. This is what the back of the unit looks like, and so here's my RF connector. I've got 3 sets of fans in the front and 3 in the back. And you know, why so many fans? Basically, we run them at variable speeds. We have this environmental control, which basically, if everything's fine at 25 degrees C and everything's operating fine, I'm going to be running the fans at a fairly low speed. I'm just going to continue an airflow. If I start having issues with the temperature, if the AC goes out, I'm going to continue to run it. I want to keep my power amplifier and the equipment running at the specifications to keep the signal going first, and then second, to keep the efficiency. Okay. Not going to go into this now other than standard. These are standard DAB frequencies. If you're into this kind of thing, this is what's used to connect up to the head-end equipment. Okay, now, this is the part I like. And because I live here, I think I picked a few different spots so I could actually give you an idea what the coverage would look like for 300, 600, and for 1,000 watt transmitters at DAB. So the criteria was minimum field strength is 34.4 dB per microvolt per meter. That was the standard that we mapped to. So on my legend, I have, for example, that light blue is 35 to 55, 55 to 75, 75 to 100 is a really, really dense coverage. This is a 300 watt coverage, and let me take a look at where this was. I think I did them in Mcot. This is Udon Thani, 300 watt coverage. Here's 600 watt coverage in Udon Thani. Again, just 4 rack space unit. Simple antenna, 8 dB antenna gain at 120 meters. Pretty high. This is 1,200 watts coverage. So you can see if you go back to 600, for example, what happens is if you look at the dark blue areas, the coverage in and around the city really gets better and not the overall distance. Okay, now this is Mcot. Mcot at 300 watts. 600 watts, 1,200 watts. Okay, where we are now, everybody knows this one. 300 watts in Bangkok. Bangkok has beautiful transmission coverage. So this is 300 watt coverage. So I think there was a question that came up about what is the difference between cells in a single frequency network and how many kilometers? Well, you can easily see 47 kilometers here. Same frequency band. We're in band 3. 600. Now, here's 1,200. 1.2 kilowatts. And I can tell you today, I live in Chonburi in the Bangsan area, and I've seen DVB-T2 coverage from Bangkok down into Bangsan easy. So, and I don't know, probably running 5 kilowatt, 10 kilowatt. Okay, so that's it. Basically, it was a primer. I tried to mix a bunch of things together. I wasn't sure what to expect here. If you have any questions for me, please approach me and I'll give you my business cards, or you can contact me through our local folks here. But I'm here in Thailand, so I'm in your same time zone. If you need to talk to me, I'll be happy to help you with anything on DAB. Thank you. ขอบคุณครับ
So, Mr. Massa, on behalf of Mcot Company Limited, I'd like to say thank you for your inspiration and stimulation for our new DAB. So we hope to see you next time. Thank you very much.
ค่ะขอบคุณมากนะคะช่วงเช้าก็จบไปแล้วนะคะเดี๋ยวพักรับประทานอาหารนะคะจนถึงบ่ายโมงครึ่งค่ะช่วงเซสชันบ่ายนะคะจะมีอีก2เซสชันนะคะจะมีในเรื่องของวิดีโอออนไลน์ไลฟ์สตรีมมิ่งนะคะแล้วก็ในเรื่องของ Digital Marketing for Broadcaster ค่ะค่ะตอนนี้รับประทานอาหารได้เลยค่ะ
ไปเรียบร้อยแล้วนะครับสำหรับงานในช่วงเช้านะครับเดี๋ยวเมื่อวานเนี่ยทีมงานได้มีการไปถ่ายทำบรรยากาศเมื่อวานมาพร้อมทั้งไปสัมภาษณ์นะครับฮาร์ดแวร์อุปกรณ์ต่างๆนะครับของผู้ผลิตนะครับแล้วก็เดี๋ยวเที่ยงนี้ระหว่างที่เราทานข้าวกันนะครับฝ่ายผลิตรายการของอสมทเราได้ไปถ่ายทำสถานที่ท่องเที่ยวต่างๆนะครับไม่ว่าจะเป็นพัทยาหัวหินหรือชะอำนะครับระหว่างทานอาหารเราก็จะได้ดูเพลินๆกันนะครับเดี๋ยวช่วงบ่ายกลับมาพบกับผมกับพี่ศักดิ์สิทธิ์ได้เหมือนเดิมนะครับอันนี้เราลาไปก่อนกลับมาพบกันอีกทีบ่ายโมงนะครับผม
สวัสดีครับผมศิวกร จันทรเสนานะครับทำงานเป็นเซลล์เอนจิเนียร์ที่บริษัทวูดเดอร์แอนด์ชวาร์ครับวันนี้ที่เราจะนำเสนอก็คือเป็นตัวผลิตภัณฑ์เครื่องมือวัดแล้วก็เครื่องมือส่งสัญญาณทีวีดิจิตอลแล้วก็เครื่องมือวัดแล้วก็เครื่องมือส่งสัญญาณวิทยุดิจิตอลครับหรือว่าในระบบของ DAB+ ในทีวีก็จะเรียกว่า DAB T2 ครับก็คือตัวนี้จะเป็นเครื่องมือที่เรียกว่าเป็น handheld receiver ซึ่งจะใช้วัดสัญญาณในพื้นที่ครับผมก็คือในเวลาที่จะต้องไปติดตั้งเครื่องส่งหรือทำการวัดความครอบคลุมของสัญญาณในระบบสัญญาณดิจิตอลเนี่ยครับก็จะใช้เป็นเครื่องมือนี้วัดพวกค่าสเปกตรัมหรือว่าจะเป็นค่า power meter ครับผมครับทีนี้ก็จะมีการดูว่าค่าภาพที่เราส่งสัญญาณออกไปเนี่ยมีคุณภาพดีแค่ไหนครับจากค่าพารามิเตอร์เช่น C/N หรือว่าค่า power เป็นต้นครับทีนี้ก็จะเป็นอย่างวิดีโอตัวนี้ที่ผมนำมาเสนอก็คือเป็นเหมือนขั้นตอนการผลิตเครื่องส่งโทรทัศน์ของเรานะครับในโรงงานที่ไทสนาคโรงงานนี้เป็นโรงงานที่ได้รับรางวัลประมาณ3ปีซ้อนแล้วในเรื่องโรงงานที่ดีที่สุดในเยอรมันครับผมคือขั้นตอนการผลิตของเราเนี่ยประมาณอุปกรณ์ทุกอย่างประมาณ 90% ของเราจะผลิตเองที่โรงงานทั้งหมดทุกขั้นตอนครับไม่ว่าจะเป็นการกลึงเหล็กหรือว่าการทำพับเหล็กนะครับซึ่งทำให้เราเนี่ยเป็นผู้เชี่ยวชาญที่ทำผลิตเครื่องส่งมาประมาณ80 กว่าปีแล้วครับทุกอย่างจะส่วนใหญ่เนี่ยอุปกรณ์ที่ต้องใช้ความแม่นยำเที่ยงตรงสูงจะใช้เครื่องมือใช้เครื่องจักรแล้วก็ใช้คนในการปรับจูนขั้นสุดท้ายอีกทีหนึ่งครับอย่างตัวนี้จะเป็นเหมือนกับเครื่องส่งสัญญาณเป็นคล้ายๆเครื่องส่งขนาดย่อยๆเพื่อส่งสัญญาณtransport stream มาให้ตัวนี้ครับภาพที่เห็นตัวนี้เป็นเกิดจากเครื่องนี้นะครับแล้วก็ต่อไปมาดูฝั่งวิทยุกันบ้างแล้วกันครับวิทยุตัวนี้เป็นเครื่องส่งวิทยุขนาดย่อมของเราประมาณ100 วัตต์นะครับของเป็นเทคโนโลยี DAB+ ครับซึ่งคาดว่าน่าจะเกิดขึ้นในอนาคตครับเราเลยนำมาเสนอก็เป็นเทคโนโลยีที่ค่อนข้างจะเรียกได้ว่าใหม่เป็นวิทยุดิจิตอลที่สามารถแทรกภาพหรือว่าตัวอักษรหรือว่าทำตัวอักษรวิ่งหรือในอย่างเช่นในยกตัวอย่างในกรุงเทพถ้าเกิดมีรถติดจะแสดงภาพการจราจรติดขัดอะไรเงี้ยเพื่อเป็นประโยชน์ของสาธารณชนได้นอกจากการฟังแค่วิทยุอย่างเดียวพวกนี้คือสามารถแทรกภาพโฆษณาหรือภาพที่มีประโยชน์ขึ้นไปได้ครับจะเป็นข้อดีของวิทยุดิจิตอลและในความถี่แค่7 เมกะเฮิรตซ์สามารถรองรับได้มากกว่า70 สถานีหรือ70 ขึ้นความถี่ครับ